What if your thoughts weren't just electric sparks, but quantum events? Some of the world's top scientists, including Nobel laureate Roger Penrose, have proposed that consciousness might depend on quantum mechanics, the same physics that governs subatomic particles and probability waves. It sounds wild, but what if awareness itself arises from the weirdest rules in nature? Let's start with the question science still can't answer. How does matter, simple atoms and molecules, produce subjective experience? You can simulate thought, measure brain waves, or model neurons, but where does the feeling of being you actually come from? That's the hard problem of consciousness, coined by philosopher David Chalmers. Most neuroscience assumes that consciousness emerges from neural complexity. But Penrose and anesthesiologist Stuart Hameroff took a different approach. Maybe the brain doesn't simulate quantum effects, it uses them. Their theory is called Orchestrated Objective Reduction, or Orch-OR. It's built on three bold ideas. First, quantum states can exist in tiny structures inside neurons called microtubules. These are like scaffolding that help transport materials within the cell. Second, these microtubules might maintain quantum coherence, meaning their states are connected and synchronized like a microscopic quantum network. Finally, when that coherence collapses, it triggers a moment of conscious experience, an orchestrated reduction that could align with what we perceive as awareness. In simple terms, your brain might not just process information, it could be collapsing wave functions billions of times per second to create the stream of consciousness you experience. Penrose's reasoning came from Gödel's incompleteness theorem, which suggests that human understanding can't be fully explained by formal computation. If true, something non-computational, perhaps quantum, must be at work. Now critics have a field day with this idea. The brain is warm, wet and noisy, which is usually the enemy of quantum coherence. Quantum states collapse quickly in such environments, long before they could influence thought. But here's the twist. Biology keeps surprising us. We've found quantum tunneling in enzymes, quantum coherence in photosynthesis, and entanglement in bird navigation. These show that quantum effects can survive in living systems, if evolution finds a use for them. So maybe the brain, with its immense complexity, has learned the same trick. Recent experiments even hint that microtubules vibrate at terahertz frequencies, possibly interacting with neural firing patterns. It's not proof, but it's intriguing data. If the quantum brain idea holds any truth, it could reshape neuroscience, physics, and philosophy all at once. It would mean the mind is not just a product of the universe, it's woven into its quantum fabric. It could connect consciousness, quantum gravity, and even the structure of space-time itself. Even if the theory turns out to be wrong, it forces us to ask better questions about what consciousness really is and what the laws of physics might be missing. If you enjoy this type of content, please press that subscribe button and comment below what you find most fascinating about the quantum brain theory.